Hey guys, Vladimir here with Desktop Makes, and I've got another great project for you today that involves Fusion 360, 3D printing, and some electronics. But rather than explaining it first, why don't I start with a little clip of the demo video. I got the idea for this project after doing the video on designing and 3D printing your own Slinky. So I was actually just kind of sitting back, twisting it, and I realized it actually looks like it's dancing. So of course the next logical step was to make it dance. So what I did was I designed this assembly that comes with a gear and then the Slinky together in one print. So basically at this point it's a coil. It's not really a Slinky, but it uses the same approach. Same approach I use in designing the Slinky, I applied here. I just used less coils. So as you turn this, as you can see, as it twists, it looks like it's dancing. So I printed two of these, and the center gear that I have a cutout here that will attach to a servo horn. So I've got my servo motor here with the center gear, and as the center gear turns, you can see it meshes with these outer gears and makes it dance. Now for the lighting, I'm using the Circuit Playground by Adafruit and also a NeoPixel ring. Now these have these LEDs that are individually addressable, and they're RGB LEDs, so you can make them any color you want. So using that, I was able to program them to make that really nice lighting effect that you see. But that's not it. So the Circuit Playground also has a sound sensor, among other, well, whole bunch of sensors actually. So I thought, why not make this be reactive so that it'll only dance when it hears music, or in this case, sound. So I'll show you what I mean. I'm gonna plug it into, this is just a 5-volt power supply here. Okay, so first it just takes background readings and then it averages to figure out what the background level is. And then if anything goes over it, it starts moving. So as you can see, it's reacting to my voice right now. So when I talk, it moves. But you can have fun with this. So you can make it move to anything, right? So if you play an instrument, I can just grab my guitar and as you can see, you can get creative with this. I also envision it being used as a picture frame on the wall. So for example, if you're throwing a party, whenever the music comes on, you get the dancing and a little light show to go with it. I'm going to leave the STL files and the Arduino code on my website so that if you want to print your own or experiment with it, you can freely grab those. And just have fun with it. And if you come with anything creative that I didn't think of, definitely let me know. All right, let's go ahead and I'll show you guys how I assembled this. I printed all the parts using a clear PLA because I wanted it to be able to reflect all the different NeoPixel colors. To begin assembly, I started with the servo motor, which I attached to the frame using 4 M3 nuts and bolts, and I actually modeled a little slit through the side of the frame where I came in with the servo wire and just concealed it in there. To attach the spring, I inserted the bushing and then secured it to the frame with a pin, and then at the top I inserted the bar that goes through the frame and also through the top of the springs. I attached the servo horn to the 3D printed gear using these two small screws, and then I went ahead and rotated my servo positioning to a middle position. It can turn between 0 and 180 degrees, so I set it to about a 90-degree positioning and attached the gear to the servo with that servo screw. Then I glued these M3 nuts to one of the springs and attached the Circuit Playground, screwed those into place with M3 screws, and then came in with hot glue gun, which I only really needed for for the NeoPixel ring. And of course, no project is complete without zip tie, so I zip tied the wires into place and then plugged my circuit playground in, and it was ready to go. Here's the finished model. Now, in reality, these springs would be attached to this upper rod through these openings, and they would be stretched out across the length. But I wasn't sure of a simple way to show that in Fusion 360, so I'm just going to display it like this. Now, when I approach a design for the first time, I usually just jump right in and just start making stuff and seeing what works, what doesn't, how it's going to fit together. And it's a process. Eventually, I get to where I need to be, but it's not pretty. And when I take a step back and look at my model, my timeline is usually a mess. You'll see all these deleted items and a lot of sort of going back and forth. And then under my browser, you'll see components that I ended up removing or deleting, and in some cases, bodies that should have been components but ended up just being bodies because I forgot to switch back and forth. But that's okay because it's kind of like the first draft. And at this point, I'm just trying to figure out how to get to where I need to be. And once I get there and I have that sort of clear roadmap of how to get where I'm going, I then would just start a new design and then, apply a more efficient method. Okay, I went ahead and removed some more components that I wasn't using just to further simplify this. And I'll hit Shift N to toggle my colors back on, and this will make it just a lot easier to distinguish between the different components. I'm not going to go over how to design each of these parts because there's just way too much for a YouTube video. Plus, this project is actually a mashup of different tutorials I've already done. For example, the spring, you can see how to design this by checking out my designing a slinky with Fusion 360 tutorial. And the gears, I also did a video showing how to design and modify gears, which involves bringing it in from McMaster Car and then going ahead and putting in my mounting holes and going ahead and modifying it to fit my servo horn here. So it's the same approach I took. You can check out both of those tutorials and that'll show you how to design each of these parts. However, I am going to show you a really neat feature in Fusion 360, which involves taking a component from one design and exporting it to another design, which ends up saving a lot of time. So, for example, I can take this spring here, this whole assembly, with the gear and the spring, and instead of redesigning it, I can say, well, this part is actually perfect. I can copy it and then paste it into a different design. Okay, so I'll briefly go over the assembly here, and I'll start with this outside box, which is the frame. So I'm gonna right click and go down to isolate. And so I have the frame, and I also brought in the servo motor. So I actually looked up the specs and modeled that, and I also brought in the horn with it. Okay, let's minimize that. And then let's see, we'll start with, I'll show you my, we'll go with the right and left spring, but I needed a way to be able to hold these down and allow them to spin. So what I modeled was what I'm calling the bushings here. And the way these work is if I bring these springs back in, they basically slide right on top of the springs and hold them down. And I'll bring an analysis here so you can see. So the way they sit is that they will actually go right inside the springs here and sit right on top of this part of the frame. And the way I actually hold them down is I model these holding rods. So let me untoggle analysis and I'll show you holding rods. And these just slide right in. So let me show those more clearly by isolating that. So it's just basically just kind of a pin that I modeled to kind of stick in to just hold everything in place. So that's gonna hold everything together with these springs being held in the bottom by the rods and the top by this top rod. They'll stay in place and be allowed to spin. So that's basically the assembly. I mean, to model the top here, I actually did a simple version of the circuit playground, showing basically just the dimensions I needed, which was just the diameter there and then the power connector, just to use that to model just a little opening here on top where it's going to sit through. And I did the same thing here. On this side, we're going to use NeoPixel ring, and I just kind of use the dimensions there, to go ahead and make a little lip for it to sit. So that's basically the assembly and how this actually goes together. Okay, let's look at how to take one component from a design and copy it to a different design. So it's quite easy to do. You just simply have to find your component on your browser. So if I click on this, you'll see that it'll highlight here, or actually underline. So, and I also know that that's the left spring. So I can simply select that and just hit Control C for copy. Now, what you want to make sure is that it is a component. You won't be able to do it with bodies. So for example, if you have a body you want to copy, you'll first have to right click and go to create components from body. So once you turn that into a component, then you should be good to go. Okay, so since we've already copied this left spring, I'm going to go into my new design here, which I went ahead and created just the frame. And I'm going to go up to the top of the browser here, right click, and go down to paste new, which is right here, and I'll click on that, and that'll bring it right into my new design, and I can put it wherever I want. I'm gonna move it over here for now, click OK, and I'm actually gonna go ahead and activate the top of my browser here. Okay, so now that I have that in, I can start assembling. So what I would do is go back to this design basically and just bring all the other parts in that I needed, and then I can just assemble them here. And to assemble this, I'm going to use a joint. So I'm going to hit J for joint, and I'm going to capture that position. And I can just simply, I know that I want the top here of this gear to be aligned with this top portion here, so I can simply once I hit J for joint, I have this box that allows me to select my first component, and I'm going to choose that that surface there, and then come back here. It's going to highlight my component number 2, and I'm just gonna, you can either select, I mean, once, it really doesn't matter here, because if it's a circle, for example, and you highlight the outer ridge, you'll see that it'll also show that center point. So I'm gonna select that, and right now it's automatically set to a revolute, which is perfect. That's what I want. But you can notice you can change the type of joint you want, and I'm gonna click OK, and that joint is all set there. So I have this little flag here, you can see. If I grab that, it gives me, double click on it, it gives me that little widget that I can then use that to turn you know, my joints. I'll probably do a later video all about joints to show you some more, you know, go into a lot more detail on this. But so basically what I'll do now is just bring in the rest of my components, apply the kind of joints that I want to them, and just finish up this assembly. Okay, for those interested, I'll briefly go through my Arduino code that I used, and I'll first begin by saying that I am a complete novice when it comes to programming. However, I'm able to get by with my limited knowledge, so I thought I would just briefly go through this for those who are interested, and I'll just kind of briefly point out what I believe to be the important parts. So the first thing you're going to come across if you're trying to control servo motors and NeoPixel lights, you'll soon realize you can't just do that without installing this Adafruit Tyco servo library. There's some timing issue there, and if you go into the Learn section on Adafruit's website, they go into depth on why you need that. But make sure to install that. And since I'm using NeoPixel rings and the Circuit Playground, I've installed those libraries as well. And then I have some declarations here, for example, my servo pins, the pin number, the number of pixels. I go ahead and declare all my variables for red, green, blue, and white NeoPixel light values. I just set those to 0 for now. And then some self-explanatory variables here where I'm storing my sound level, declaring a threshold. Now increment here, this is the amount that I want my servo motor to increase after each step. So, you can make it go faster or slower by changing this number. And then also this interval number here. This actually was going to control the amount of milliseconds that I'm going to have it wait before moving my servos. And then so I do declare this other variable called previous millis or millis because I'm going to be using the millis command. Now the reason I'm doing this is because you don't want to rely on delay statements when you're trying to control servos and NeoPixels, because timing is so critical here. So you actually have to keep track of how much time has gone by and then tell your microcontroller, when to make certain decisions. So I'll go into my setup here. Oh, actually, before that, this part here with my NeoPixel and the NeoPixel ring. So you want to tell it the number of NeoPixels, which pin, and this part was very important. I wasn't able to get anything to work until I actually got this part right. So this is saying, because I'm using the green, red, blue, and white NeoPixel rings, you have to make sure you have the right declaration there, and the one that includes the white, or else your ring won't work. Okay, so in my setup, basically what I'm doing here is I'm gonna have the Circuit Playground just listen to the background and then take 5 background readings and then calculate what my background level is. And it's just reading. I'm not doing anything fancy here. I'm just getting raw background data. So if you look at this part of the loop here, I set a loop and I say go ahead, listen to the Circuit Playground. So all you do is you want to take that Circuit Playground.sound sensor, and that's going to bring in that raw value, and I'm just adding it, taking a reading every half a second and then dividing that by 5 to give me an average reading. And then I have this threshold here, which just says, whatever that average was, my threshold is going to be that plus 20. You can experiment to what number works for you, but I'm just setting whenever that sound level goes to what my average is plus 20, then this is again the raw data, then we're going to do something. Another thing actually I'll point out here is I set the brightness to 255. That's maximum brightness for the Circuit Playground and the NeoPixel rings. Default, it's set a lot lower, because so you don't go blind basically. But because I'm trying to get maximum brightness here, I set it all the way up. And you want to be careful here because this will definitely increase how much amps you're going to be pulling when you increase that brightness. Okay, let's go ahead and jump into the loop. And so what I do here is I'm just getting that raw data from the sensor, and then just an if statement here. If that raw data, which I'm storing into this variable called value, if that's greater than the threshold and if enough time has gone by, go ahead and do something. And in this case is we're gonna move the servo. So if these conditions are true, we'll move the servo position. And then we'll just increase and decrease that depending on where the servo is. And then also I want to control the NeoPixel lights at the same time. So what I really end up doing in order to keep it simple is I just piggyback off the servo positioning. So where I declare my NeoPixel colors, so I've got Circuit Playground.set pixel color, and then which NeoPixel, and then this is my RGB value. So my red, I set that to position. Green, I have this set to 0, and then blue, I have that set to sort of the inverse, which is going to be 180 minus positioning. So as this red goes up, blue will be going down. And you can play with these to get whatever kind of color combinations you want. Now with the NeoPixels, I can give it a value between 0 and 255. In the servo, I can only go between 0 and 180. So if you want to have that full range, you'll have to get a little creative with the math. But to keep it simple, I just kept it between 0 and 180 to set my NeoPixel colors, so that it just corresponded with my servo positionings, and that just kept it simple. And it does give me some nice colors. So again, you can go and play with that and get, to get whatever colors you want. And then I do the same thing for my NeoPixel ring. So I'm just sending that to my NeoPixel ring as well as my circuit playground. And that's about it. So that's kind of that in a nutshell. I hope I explained it right, what I did. Like I said, I'm a novice in programming, and I'm learning as I go. And I know you can do a lot more with this code. I'd love to go back later and optimize it to actually be able to detect the beat and follow it, and pick up the different pitch in the songs and move to that. So maybe one of you can actually help me do that, or if you see any way to optimize this and make it better, let me know. I'd love to learn. So all right, I hope this was helpful. All right, let me know what you guys thought of this project in the comments below, or if you have any other ideas of how you would use this or optimize it, I would love to hear it. If you're looking to learn how to design for 3D printing with Fusion 360, check out my courses at desktopmakes.com.